And let me take over the Zoom pop-up. That's it. Hello, everybody. Welcome to our last meetup in the 2021 Container Series organized by the AWS User Group Dubai. So, in the first week, we actually learned why we may want to use containers and how we can actually use containers. In the second week, we learned how to build containers and how to actually store container images. We had both the talk and the workshop. And today, ending up this series is Walid, who will be presenting a talk on Kubernetes and EKS. Again, this is the last talk in the series of 2021 container series organized by the user group. This was all possible due to our lovely sponsor, AMD. So thank you, AMD, for sponsoring this. Again, this was a community effort. So if you want to see more talks like this, if you want to see any specific topics or any other deep dives, or maybe if you want to talk, definitely reach out. This is a community. This is a user group. All that said, I'm just gonna pass it off to Walid, who will be teaching us Kubernetes. Walid, you have the floor.
Thank you, Vlad. And thank you for the workshop and all the presentations you have done so far. The feedback is really awesome. And thank you, Anas, for doing this. Okay, let's start. So this is, as Vlad said, part 4, and hopefully it's the last part, but not the least. Okay, I cannot say this when it comes to Vlad. But hopefully we're going to have other series and we're going to have other presentations that will complement and answer some of the questions we have. Thank you, our sponsors, AMD, and thank you, Amazon Web Services, for your support. And thank you, AWS User Group Dubai, for hosting us and for hosting this lovely series. I hope everybody enjoys the series, and I hope that I'll be give at least something useful today, as Vlad did before. So we have 3 AWS heroes that are backing me up and making me honest. I should lay back and start. Okay, who am I? I'm just Walid Shari at Twitter, and this is my LinkedIn, this is my GitHub. I have the trifecta of Linux Foundation certificates and AWS Associate, Red Hat Certified Architect 5, which means that I know a lot of Red Hat and I forget a lot already. And Azure Administrator, which actually I forgot, but I use it. For the last 2 years, I am using it a little bit more than AWS. I'm leading the DEMAM Cloud Native AWS Meetup, and I'm leading the DEMAM Docker Meetup, which is quite idle for the last 2 years, mostly focusing on the other meetups. So what are we getting today? Quick review of what Vlad said. We're going to make you some questions. What problem are we trying to solve? Some introduction to Kubernetes, and basically we'll do some ad hoc exploration. I wanted to, I wasn't really sure, should we do installation or should we go to deployment or should what we do? So I said at the end, let's do some explorations, and I want to explore more EKS Anywhere, which was released like 2 weeks ago, last Wednesday. So it's around like 2 weeks really. And when I checked, the abstract that I gave is basically too much. It cannot be finished in 2 hours. So let's see. News. I love to start with the news, the TGIK way and the other Echo webcast way. So what's the news? Okay, AWS Community Summit UK. Agenda is now live. Please register. There are lovely talks, especially for people interested in security. Liz Rice, a container here, will be there. And Steve Gudjera, I'm pronouncing his surname wrong, but he's a very active cloud native security, and he has his own webcast, Clusterfuck. Sorry, guys, but that's how he pronounces it. Okay, and so this is the cloud native side. Now go back to the AWS side. KubeCon is coming October 11, 15, and we will have again AWS Container Day in KubeCon. It will be one of the day 0 event, I guess, on October 12th. So make sure that you register. There will be like vouchers to give away, and there will be a very interesting and talks and maybe even announcement on roadmaps and stuff like that, like last time. So make sure to check it. There is even cooking recipe last time. Okay, and last but not least, SneakCon. And they will have capture the flag for containers and Kubernetes security, and most likely they will use their own tool. And this tool helps securing your software development life cycle and making you shift left more. And that's what GitHub is using, if I recall correctly. Okay, and as usual, we'll have 3 vouchers to give away for the best engagement. No questions, please, because today it's me. So please, questions to Vlad only, but to me, please give me answers and give me an easy way. No, the best engagement will get vouchers, hopefully. Okay, so review, containers. What did we learn from Vlad in the last 3 days, 3 sessions before? So basically, we learned that containers can be a packaging mechanism. It's basically you can build your software, distribute it, and run application almost anywhere where there is a container runtime. Main benefits of containers is the isolate application from each other, which is a great benefit. It utilizes Linux kernel features like namespace, C groups, AppArmor, and SE Linux to maintain this isolation and to maintain balanced resource utilization. Of course, I mean, I am from the camp that says containers are Linux, but there is another camp which says containers are also Microsoft Windows, and Microsoft have different types of containers, and they are getting popular. I really don't know why, but I can see that our users also demanding Windows containers. Containers can be considered as lightweight virtualization or lightweight application virtualization. As you can see that containers share the kernel, but the host kernel, but they don't have the overhead of the hypervisor and the operating system. And instead of running 20 VMs or up to 40 VMs per hypervisor, now you can run hundreds of containers or 200s of bots. I think now the default for AWS, if you are using the latest CNI, is over 500. It depends on the CNI you are using. Okay, and containers, Docker was the main drive. Docker democratized the containers, but we do have other container runtime, Containerd from Docker and Cryo from IBM, Red Hat, and Google. It's mostly Red Hat, but it's an effort by several vendors. This is from AWS Gig, and I like it. I couldn't find the webcast. Most likely they didn't share the recording. This is from Bahrain Summit 2019, before the lockdown. And this presentation was very holistic. I don't know how he did it, the presenter, but it was very holistic. And it presents the move from monolith to microservices and what are the challenges and what are the different tooling that is available in AWS. So in general, hosting container AWS, you have ECS and EKS. ECS is the simplest orchestration. EKS is the open source standard Kubernetes orchestration platform that you can migrate your application across the cloud from other clouds to AWS or from AWS to other clouds and on-prem. To manage containers, basically, you need a VM, you need a host. So the host for us is the EC2 instance, and EC2 instance type do matter, and the operating system do matter. And if you want to go the serverless way, we learned from Vlad that we have something called Fargate, and it helps us in managing the containers the serverless way. So we forget our infrastructure. We don't need to handle the operations of the infrastructure, and we focus on the core application. Application is the king. We should focus on the applications. Okay. The AWS open source community is contributing big time to the container movement and to Kubernetes. They are part of etcd, and they are part of cluster ABI and part of lots of Kubernetes SIGs. Containers basically help in discovery, help in breaking application to microservices. There is no bad or good between monolith and microservices. They are basically both software engineering architectures, and it depends on your use case. So it could be, while during prototyping, it could be the monolith is better, or if you have a small team, maybe the monolith is better. If you have large team and you have different polyglot languages and applications, maybe microservices is the one for you.
I have a question that I'm very sorry, but I have a question in this part.
I don't see. I don't see who's asking the question. So yeah.
This is Muhammad Atiyah. How are
Hello,
you?
Muhammad. Yes, you can distract me, Muhammad. By the way, I am very easy to distract. So go ahead.
Sorry to interrupt you.
No, go ahead. Go ahead.
How's the conversion goes? So if I have a Python code as an example, and I have multiple functions and strings and everything inside it running, like a big application, and I'm calling another Python file and everything. So in your experience, how this digitization, or I mean changing to a microservices takes place? Can you give me just a small example?
In my experience, it's difficult. In my experience from our developers, I present operations. But our developers, they are stuck with lots of questions because basically they are trying to boil the ocean. I think if you handle it gradually, like for example, as you said, you will have different modules. You have something for authentication, you have something for authorization, you have something for, I don't know, for the business logic and stuff like this. So if you take out the centralized functions like authentication and authorization and monitoring and stuff like this, maybe this is the way to do it. If you take out the infrastructure management, like do you need to do TLS, mutual TLS inside the application, or you can use what we call service mesh outside, which is app mesh in AWS. So the answer, it depends, and it's actually depends also on your teams and their skill set, and can they handle the migration or not. I am part of Udacity Cloud Native Architecture course, and we are learning how to do this the gradual way, bit by bit. So it's.
Got it. Thank you so much.
We can discuss this offline, and maybe Vlad or Sadi can basically give you more, or Anas from their experience.
Thank you.
Okay. So I recommend this. I will try to reach the EMEA team to see if they can put the recording online, because I think this was one of the best presentations I have seen. It's very holistic. Okay. Now, Vlad talked about this in the first session, that there are different ways to run containers on the AWS. And this can be for, you can run container image as Lambda, or you can change a container image to Lambda function. You can run EKS, Kubernetes, or you can OpenShift on AWS, which is called Rosa. And again, Corey found, if you read the blog of Corey, or if you are subscribed to his mailing list, he found another 17 more ways to run containers. So basically, containers are everywhere. They are pervasive, and they are everywhere in terms of infrastructure, in terms of services. If you don't know this, by the way, IBM Cloud is built on top of containers. They are built on top of what it's called ICB before, IBM Cloud something. And now it's basically all the VMs, all the functionality is basically on top of a container platform. What I care about is the role of containers. We saw that with VMs. The moment we move to VMs, everybody is asking for a test VM, quality assurance VM, and it became unmanageable. The same thing will happen with containers. So why I'm saying this? Because this is the problem. This is the problem that we are trying to solve with orchestration, Kubernetes. One problem is the sprawl of things and becoming unmanageable. The second problem is what AWS CTO Werner Vogel says: everything fails all the time. So when you design your application, especially you, Muhammad, and you make it microservice, make sure that you have this mindset in your mind. Everything fails all the time. So make sure that you have the redundancy, resiliency, availability as part of your day zero consideration, security, and all this. Make sure that it's part. The one thing that I want, the key takeaway, I don't care if you learn Kubernetes or if you learn what, but if you make this statement, if you take this statement from Werner, I think we will be in a good shape. Okay, so what is Kubernetes? I keep babbling about Kubernetes and the problem that we need to solve. So the problem we need to solve is that Vlad showed us containers and showed us how to pull them, push them, build them, run them. And one thing about containers, they are very fast. They can be brought up fast, they can be terminated fast, they can be set up and terminated very fast. However, all this was happening in a single host. So we didn't cover multi-host. We can cover multi-host using ECS clusters, but we didn't. So what if I am successful and my applications want to scale? What should I do? I need orchestrator. One of the orchestrators that took the world by storm, and it still has an exponential growth in itself and in its ecosystem, is Kubernetes. What does it mean? In Greek term, it means helmsman. In the internal project name, the internal project name in Google when it started, I think it was called Seven, based on the Star Trek. If you are a Trekkie, you would know Seven. She's a nice lady in, I think, Discovery. Okay, and she's like, she's the Borg in, is she half Borg or she is a Borg?
She was rescued from Borg. If you
okay, but she's the liaison between humans, between other, I mean,
yes,
other species and Borg.
yes,
yeah, okay, and Borg, and that brings us to the history of Kubernetes. So Kubernetes, I mean, there is lessons learned in how to build distributed infrastructure and how to manage containers. 15 years in Google using Borg because they were upset with Borg. There's lots of people who don't like Borg or the way it was done, and they try to do their best when Kubernetes started. That was 7 years ago, and it started in AWS in 2017 officially. They managed Kubernetes EKS, but it started 2015 when it was donated to the CNCF Foundation. So it is an open source project. You can consider it as the data center operating system, the kernel of distributed system. If you are running distributed system, think of it as the brains behind and how to run and manage and deploy this operating system. Think about it as the Linux of the cloud. It's a platform and container orchestration for automating deployment, scaling operations, and application containers. It's a platform for platforms, really, and we will see this. Kubernetes basically now can support any runtime, any container runtime that supports the CNI, CNI, not CNI, sorry. No, it is the CNI. CS, oh man, I forgot. Sorry?
CNI is Container Network Interface.
Yeah, it's not the CNI, it's not, it's the Container Runtime Interface, the CRI, and that's where CRI comes from. So CRI is one of the container runtimes, and its name comes from the standard, the Container Runtime Interface. So Kubernetes can support any container runtime interface. If you write your own, it will support it. Okay. What I like, what's the definition I like about Kubernetes? I like the one from Kelsey Hightower, where he says, Kubernetes is a platform for building platforms. It's not the end game. It's a place to start. So I really like that, because basically what you can build on top of Kubernetes, you can build another platforms like what? Like data science platform, like a serverless platform, a function as a service, you name it. You can basically build any platform you think, platform as a service, or like Heroku or whatever, yeah? So basically, don't think of Kubernetes as the end game. Think of it as a platform to create another platform that will be usable by end users. The other definition that I like from the Wikipedia, this is the definition from the Wikipedia, but I like the definition from VMware, where basically Kubernetes is the data center. Okay, so what problem we are trying to solve? The problem we are trying to solve is application delivery. I want to develop an application on my laptop, on my workstation, and I want to share it with my workers. I want to share it with the enterprise users. I don't want it works on my laptop. It doesn't work in another environment. It should work on my laptop. It should work on-prem. It should work on any cloud. And this brings us to EKS Anywhere. So I love the name EKS Anywhere. I had this presentation before Anywhere. So I love really the name EKS Anywhere, because basically that's the goal. That's the end goal that we want, is that we will be able to run our application regardless, monolithic microservices anywhere. And what does that mean? That means that the application should be scalable, should be resilient, should be reliable, and should have security in mind. And how Kubernetes does this? It abstracts. So the only way I can run it anywhere, if I can abstract the underlay, if I can abstract the infrastructure, if I can abstract the VMware cloud from the AWS cloud, from the Azure cloud, from the IBM cloud, and so on. Okay, 3 core concepts. Okay, these 3 core concepts, I wish that I knew about them in the beginning, especially when dealing with RBAC and roles and role binding and stuff like this. This is the core security of Kubernetes. That first one, Kubernetes API driven. Initially, there was like just a core API. It was not named group. And then we started having name groups, like, so API v1 is the core API, where you have the core Kubernetes object, and we'll talk about these. So for example, when you have a cluster, you have nodes. This nodes is an abstraction. What defines a node? What defines a pod? A pod is a collection of containers. Why do we need a collection of containers? Why we're not running containers by itself? Because this was one of the challenges of containers, that some containers, they depend on each other. They need to communicate with each other. Like what, for example? Like, let's say, sometimes even design patterns that require each other. Like if I need logging, if I need security, if I need things that are like what I said in the early beginning, mutual TLS, if I need secure communication between a container and container. Instead of me creating it and developing it in my application every now and then, maybe a container that can take care of this function, and it will be part of the pod. Maybe the containers depend on a network interface. Maybe they depend on a storage volume. Yeah, so that's why we create a pod. So one thing that you have to be aware of, that basically everything in Kubernetes is API. All these objects are basically API endpoints. And there is a schema that defines each one of them. Now, this command, kubectl API resources -OY, is very nice command because it will show you what API resources you have. You might have more than what somebody else has. Why? Because you can extend Kubernetes. You can extend Kubernetes with something called custom resource definitions. I know that I'm jumping, but just if you don't know this or you are new to this, just take it as it is now, and you remember it later. So basically, all the core message that I'm trying to give you on this slide, that Kubernetes is basically API driven. It's a distributed system. It's a very extensive, complex system, to be honest with you. It's not an easy system. But if you tackle it one bite at a time, I think you'll get used to it, and you'll learn it very fast. And you don't need to learn all this, because almost all of this is abstracted from you, and it makes sense. For example, here, I see something called inlets. This is a project by Alex, and this is basically to create a tunnel, like if you are in a net, or if you are behind the proxy or something like this with development, so that you can actually, from your laptop, you can communicate with the public cloud, or you can communicate with multi-clusters and other stuff. And this is an extension. This is an extension of Kubernetes. This is not part of core. Okay. So this is the first concept, and we will come to it later. So basically, the first thing, when somebody says Kubernetes, think API. When you do the kubectl command, API resources, this basically in the background, it calls a RESTful call to an endpoint. This endpoint is called API resources. Okay. Now, the second thing is reconciliation loops. Kubernetes built on the lessons learned from infrastructure as code, or as Justin Garrison says, software, and Chris Nova says software as code. What's the difference between infrastructure as code and software as code? Infrastructure as code, we are trying to remove drift, but we cannot be holistic about it. There will be still drift. We cannot control every package on the system. We cannot control every service on the system. We cannot control every infrastructure component in the system. But software as code, like in Terraform, we control the state of the system. In Kubernetes, the same thing happens. We control the state of the system. There is something called desired state. I want my application to be highly available. This highly availability, we call it, for example, replica. So I want my containers, which are, we said that they are not containers anymore, they are bots. I want them to be 2, maybe in different availability zone. So if one fails, the other is still available and will serve the connections, if there is any connections, while the one that failed will come up again. It should self-heal. How this happens? By controllers. There is so many controllers in the control plane, and we will see that basically Kubernetes has 2 parts, has the control plane and the data plane. And part of the control plane is the API server, so because everything is an API. And another part of the control plane is the controller manager, because we need the controller manager to run all these controllers. What kind of controllers? A bot controller to create bots, a replica set controller to create replica, a deployment controller to create deployment, and so on, and so on, and so on. So this is the second concept, the controller and the reconciliation loop. And remember what I said about extensions, the custom resource definitions. So the custom resource definitions is actually a controller and data definition. So basically you define a data type and you define a controller, how to handle this data type. The other concept is abstractions. We said that for Kubernetes to be successful in running bots or containers everywhere, they need to abstract the infrastructure, and we need to have a common language, how we present the applications. So everything at the end of the day comes back to the bot, most of the things, let's say, because there are things that I'm not sure, most likely, like endpoint, okay, is not a bot. But it will be related to a bot somewhere. So the central concept, the central abstraction is a bot, which is a collection of containers. From a bot, I can then define new workloads. And that's why Kubernetes every 3 months, every 3 to 4 months. It used to be every 3 months, but now it's 4 months. So every year we will have 3 releases of Kubernetes. So now, for example, we are in 122. I think we are in 122.2. So by the end of the year, we'll have 122.3 and so on. Okay, so there is a release every 4 months. It's a quick base, but still 3 releases per year. 3 releases per year is better than 4 releases per year. At least the third-party vendors and the users can have some time to upgrade and test and quality assure and integrate with the new releases. Okay. Okay, so basically everything comes back to a bot. And the bot basically abstracts the unit of execution. So the smallest unit of execution in Kubernetes is a bot. Now, if I am doing something like Kafka, for example, where there is a master and slave, and I need to keep state of the master and slave, and I need to keep the naming, maybe stateful set will work with me. But maybe if I don't care about the state, maybe if this is a stateless application, maybe I can do replica set. I will not do replica set directly. I will use something called deployment. But if this is a one-time job, and this job runs periodically, there is an abstraction called the cron job. Or if I want just a job, just an one-off batch job, there is a job. Okay. To get the bot traffic to the outside, there is the object ingress. To make sure that if I am updating, I'm doing online updates or something like this, or if bots needs to migrate, I can define a policy which is called bot disruption budget, that I say, look, this bot, don't kill it or don't migrate it unless there is another bot already running somewhere else. Okay. And if I want to scale based on threshold, based on metrics, CPU, memory, or it could be any other metric actually now. So I can do using the horizontal bot autoscaler. This is scaling for bot, and there is a scaling for nodes, for the cluster nodes, which is called the autoscaler. Services expose the bot at the cluster level, or it could expose the pod at the outer level if we are using a different type of service. Service is very overloaded object. And of course, if I cover the compute, if I cover the network, I still need the storage. So I have abstractions for storage, the volume. And I have two abstractions. I have resistant volume claim. This is what the user developer asks for. And I have a volume, which is the administrator or dynamically provided by the cloud provider. And if it's something simpler, like sharing config maps, sharing config files, or sharing config key values or something like this, maybe I can just use config map. If it's something sensitive, it could be a secret. The difference between a config map and the secret, that the secret, I can control who's using it by something called RPAC and role binding and stuff. And in EKS, we will see that the secret can be encrypted by KMS, customer managed secret. Okay. So 3 core concepts. Everything is in ABI. And the second concept, there is lots of controllers. Everything is developed as almost as a controller to maintain the desired state. And the desired state means that everything that I want from my application, I declare it. I don't imperative. I don't say exactly how it's done. I just say I want 2 replicas. I don't say how these 2 replicas will be created. Okay. Now, Kubernetes architecture overview. So we said we have a data plane and we have a control plane. In EKS, by the way, we will not see the control plane. The control plane is managed by AWS. Okay. And for example, ECS, the Elastic Container Services, the control plane is always managed by AWS. Even EKS Anywhere, the difference between EKS Anywhere and EKS Anywhere is that the control plane of EKS Anywhere is managed by AWS. But in EKS Anywhere, it's completely open source. Even if you are not a customer of AWS, you can use EKS Anywhere. It looks like I'm jumping back and forth. I mean, we didn't cover EKS and we didn't cover EKS Anywhere, but I'm talking about control plane and I'm talking about the difference between EKS Anywhere and EKS Anywhere, because I know that you are smart here and there is lots of people already know this information. And I'm hoping that I'm adding a little bit to it. Okay, now there is so many components. So this is like a high level abstraction and we'll see 2 different images again. So what's the main thing? The first core, everything is an API server. So I need an API server to interact with everything. Everything interacts through the Kube API server. Okay, but where does it save the state? How does it know how many nodes I have? How does it know which application I'm running, which container images, and the policy? Should I build the container image or should I use one that is built already on the node? This all is kept in a key value database called etcd. etcd is a distributed database developed by CoreOS. CoreOS developed lots of good stuff like Core DNS, etcd. And their vision and their goal was Google for everyone else. Is it Google for everyone else? Something like this. Yeah, so basically they wanted to create the tools and the framework that enables you to run as efficient as Google. So basically they call it Google for everyone else. The one thing that they were missing that they didn't build was the container. They didn't build the container. They used basically Docker in the beginning and then they developed their own, which was Rocket. And now it's actually decommissioned officially from the CNCF. But it introduced new concepts like the signing of containers, and it introduced the concept of lightweight container runtimes. The controller manager have all the controllers that you need, like what? Like a node controller, replica set controller, deployment controller, you name it, it will be here. If you extended your Kubernetes version, like for example, I'm using something called StackRox for security, or now it's called Red Hat Advanced Cluster Security. It comes as an operator. So most likely the operator will be here, will be a controller here. And this operator basically will check, do I have these deployments? Okay, if I don't have them, create this deployment with this specs and stuff like this. Okay, now I have the brains. I have the communication, which is the API server. I have the state, which is etcd. And I have the manpower, the controller manager, but I need the brains. The brains are the scheduler. The scheduler is a very simple scheduler, but you can replace it. When can you replace it? Like example, Fargate. Fargate actually replaces the scheduler. When you create a Fargate profile, that's what it does. It actually checks your criteria for selection. And instead of using the Kubernetes scheduler, it will use the Fargate scheduler so that it can schedule workload on Fargate instances. Okay, now the scheduler, the main responsibility is allocating the workload in the right node. And there is lots of improvement. For example, now we have a load-aware scheduler. So now, before that, before 122, I think it is not even in 122. I'm not sure, maybe it's beta or alpha in 122. But basically, what it will do, it knows that, for example, this node is 80% utilized and this node is 60% utilized. So it will favor this node instead of that node, and etc. Okay. Now, the nodes are the data plane. This is the control plane. And this is where Vlad was talking about when he's saying container and container runtime. But we have a new, when you have a new component, which is the kubelet. The kubelet, think of it as the Kubernetes agent that talks with the control plane. It says what I am running, what I can, basically, it can pull things. It can manage the sandbox where the container runs. It can manage the CNI, the container network interface. It can talk to kube proxy to make this happen. So basically, it's the brains on the node. And it has an API. And this API is really dangerous. So basically, if you are looking into security, make sure to secure the kubelet as you secure your control plane. Okay. What else I need to talk about here? Let's see it from different perspective. Here, the perspective. Yes, Muhammad, you always ask questions. I'm not going to give you a voucher if you ask questions. I need answers.
Would you rather we keep all the questions for the end of the talk, Walid?
No, it's okay. As long as I don't forget where I am, but I know where I am. Yes. Go ahead, Muhammad.
I didn't use the voucher yet, Walid.
Okay. You can return it if you want.
Yeah. The networking part. So I'm just curious about.
Okay. Yes, the networking part. Okay.
I think it's coming in the coming slide, right?
Yes. What I'm trying to say here. Okay. I mean, Kubernetes. All of this will be managed for you in AWS.
I will wait for this slide. Okay, I will listen to this slide first, and then I will.
Yes, so basically it's the same slide as before, but here it's highlighting the different traffics. So you have protobuf protocol and gRPC protocol, and everything actually, by the way, was traveling at JSON. It's not really YAML. Actually, they translate from YAML to JSON. Okay, and Joe Beda talks about it in the history of Kubernetes several times in several talks. So again, you have the control plane. It's not called master anymore since 121. It's called control plane, but you will see in roles that master control plane. So to get rid of the I don't know how you call it, like bad naming that has that can have wrong connotations. The controller managers with the controller loops, the API server, which is basically have all the endpoints for REST APIs, the scheduler, which schedules pods or workloads to nodes, and etcd is the key value data store. Okay, so in the node, I will have an operating system, and preferably it is a container-based operating system, such as Flatcar, Bottlerocket, Red Hat CoreOS, Fedora CoreOS. CoreOS, one of the things that they created was CoreOS, which is a very minimal, very easy to update, because you want to focus on the application. You don't want to focus on creating updates, and you don't want to update a package at a time. I mean, if it's a minimal operating system, why don't I update it all? And why should I have many functions that are not related to running containers? So the operating system sole purpose is to run container runtime, or run Kubernetes, or run kubelet. Okay. The container runtime could be Docker. In AWS, we saw that it could be Docker, it could be containerd, or if you provide your own custom AMI or AMI, you can override this if you need, for example, gvisor or Kata or something else. Okay, the network, as Vlad said in the beginning, CNI stands for Container Network Interface. And container network interface, you can cascade them. There was a question, I think, in the second session, can I use a different container network interface? Yes, you can. AWS can support Entria, can support CDM. Actually, EKS Anywhere is running CDM. Can support Calico, and you can do them in cascade. Why you want to do them in cascade? So that you get the benefit of both container network interfaces. Okay.
So it's an IP address based. I mean, like if I have multiple containers, how can I differentiate the networking of each part?
So Kubernetes, they took a decision, like Docker basically did. Every Docker decision is user experience related decision. So if they have two decisions and one is better from terms of user experience, they would prefer the user experience one over the other. In Kubernetes, the networking decision was to go with a flat network. What does that mean? There are like 5 assumptions regarding pods networking. And the first one, which I remember, maybe I don't remember the 4, but at least I remember the first one, that every pod has an IP address and can communicate with any other pod on the cluster, regardless of where the other pod is. So it's a flat network. So you say, how about security? Oh, for security, you have something called a network policy, which is an ABI, which is an object, which is a Kubernetes core object. It's not core object, it's part of a named group called networking. And this is where you can segregate the network. So every pod has an IP address. And the pod is basically, should be short-lived. You remember what Werner said? Everything fails. Pods fail, and they fail a lot. They migrate a lot. So the pod, you don't really care about its IP address. You care about the service IP address, because this will be the static IP address. This will be the address that will not change, and you can communicate with the bots that stay behind it. If you need me to explain it more, I can go over that. Just remind me. Okay, so this is another view. There is nothing really special about here. The kubelet is the one that manages the pod, and the kubelet, I mean, if you read about the kubelet, you'll be surprised. If you have a question, if you have a quiz, and one of the answers is kubelet, you always choose kubelet. Most likely you'll be right. Okay, now, so what did we talk about? We talked about what problem we are trying to solve, and the problem we are trying to solve by containers is application portability, application packaging, application distribution. And application distribution was established through container registries. And now we are successful with containers. We went big, so we need orchestration. Why we need orchestration? Because of scalability issue. We need something to manage our scalability. We need something to manage our failure, our self-healing, our high availability, the replications, our reliability, basically checking our readiness, checking our liveness and stuff like that. And this is part of the pod. Who was first when it comes to distributed applications and lessons learned? Heroku. And Heroku, from their customers and from the way they run their platform as a service, they developed something called the 12-factor app. And you can relate the 12-factor app to the abstractions that Kubernetes gives you, or the process, how you develop applications in Kubernetes. So the 12-factor app, if you think about them, they are, you can think about them as a software development lifecycle, like a build phase, release phase, and run phase. And these phases should be distinct. And the build phase, for example, you should have like standard code base. So this is where the polarity of Git now. I think nobody is actually debating this, and the popularity of Git and Git workflows, and in Kubernetes, the rise of the GitOps. And we will see in EKS Anywhere, it comes with Flux. Flux is the GitOps tooling from Weaveworks. Yeah. Okay. I wanted to talk about this, and I wanted to relate to it more. Okay. because it was mentioned in one of the questions before, like when we asked about what kind of things that you shouldn't really put in a container, like configurations. And Vlad answered, I think Vlad answered, there is something called the 12 factors. And so the 12 factor basically says two things about backing services and configurations. So like backing services, they are not attached to the resource. So that you cannot have, for example, your database and your front end on the same pod. Configuration, you cannot have your configuration inside the pod, or you cannot have your configuration inside the container, sorry. And services, the concept of services, as Muhammad was asking, relates to the port binding. The terms of concurrency relates to the replica sets and the stateful sets and all the replications that is happening in Kubernetes. This possibility, the fact that we consider bots will fail, and we have mechanisms to check if the bot started, if the bot is alive, if the bot is ready or not. Dev production parity, we have a concept called namespaces, which actually gives us like an isolation. Like I can have two different, and remind me later, I will show it in the example, in the exploration that we are going to do ad hoc. Okay, now this is one object. I snatched this from LinkedIn. Somebody posted it on LinkedIn and I like the way it is structured. And we will see this when we go into exploration, Argo CD. So this is a schema. This is how we define a pod. And we said the pod is the smallest unit of execution in Kubernetes. So you have to say the API version, and here you see V1. V1 means it's core API. So the core API, the old API that covers pods and covers other stuff, will be basically V1. So applications like deployment will be in a named group, named API group, which is like, for example, apps V1. Authorization will be a named group for authorization, like RBAC authorization, K8s.io V1 and stuff and so on and so on. So API is really a core concept, and it will help you on the securing your cluster and defining your roles and rollbacks. And I think even the extension, if you are going to do CRDs and stuff. So I think it's good to know more about it. How do you know which APIs? If I go here, for example, oh, sorry. Okay, we'll do it later, the exploration. Let's finish this because I'm not very good in sharing using Zoom. This is my first time actually sharing using Zoom. And as in any object, you need metadata to describe the object. So minimum, I need a name. And I said there is a concept called namespace, which is like logical zones. These logical zones can be treated as security zones. They can be treated as operational zones. So I could have dev.ns for development, and they could have prod.ns for the same application, but dev.ns presents the logical separation for development workload versus production workload. And it could be in the same cluster. Instead of having dev cluster and production cluster, they could be in the same cluster. I talked earlier about the sprawl of containers, and now I see a sprawl of clusters. And we need to manage multi-clusters. And it's amazing how people are doing multi-cluster management. Labels like tags in AWS. So labels are very nice because this is, think of the Kubernetes object are loose objects. And how do you say that this pod will be related to a service using these labels? How you say that pod of this label shouldn't run on this node using some labels again. So labels play a big role on network policies, on tying things together, on making things a whole and loosely coupled. Okay, but the meat of the thing is under spec. This is the desired state. This is where I define the desired state. So we said the pod is a collection of containers. So what's the most important thing about the container is the image name. If I put image nginx, what do I mean here? I mean, that's most likely docker.io/nginx, unless it's defined on the host that I should search from a different registry. But usually, if I just put the name I like to use the word image, but we learned from Vlad that we call this repository. So if I just put the repository name here, that means Docker, by default, most of the container host, most of the runtime, container runtime, assume that your first search registry is docker.io, the Docker Hub. You can give it a name. You can give your container a name, which makes it easy to for visibility and for troubleshooting. The DNS policy is cluster first, and that's related to service discovery. One thing why we use Kubernetes, because it gives you service discovery out of the box. It gives you self-healing out of the box. It gives you distributed system management out of the box, deployment management, application startup, application shutdown, everything out of the box. And another thing that gives you out of the box is the internal DNS, which is mostly used for service discovery. What happens if this pod dies? This is the restart policy always. So basically, this pod should restart this container. Now, remember the second concept that I have a control loop, and the control loop basically checks the desired state with the current state. And if there is if it's not matching, it tries to reconcile it. That's where the status part. So this is my desired state. Status is my current state. Okay. Okay. Hopefully I made sense. I mean, I made sense in my mind, but I hope that I made sense in your minds too. Now we come to EKS. So what is EKS? We talked about Kubernetes. So what is EKS? Why do we need EKS? EKS, as in everything in AWS, especially like EC2, starts with E, elastic. So it's an elastic service, elastic Kubernetes service. Sometimes or it's still in some publication, they call it elastic container services, but this is confusing for me because for me, ECS is the elastic container services. Anyway, it's certified Kubernetes distribution. That means certified by whom? By the CNCF, that it is an open source compliant. So basically the same APIs that runs on EKS are the same APIs that runs on OpenShift, that runs on Rancher, that runs on any other Kubernetes distribution that is CNCF compliant. How many CNCF compliant distributions? The last time I checked, over 200. But there are different cases. So some cases they will never run on-prem. Some of them are cloud only. Some of them are for special use cases. So depending on your use case, maybe you'll find a handful. Okay, so EKS is actually becoming quite pervasive. Why? After EKS distribution and EKS Anywhere, you can run EKS anywhere. You can run EKS on public cloud, AWS. You can run it on your data center using Outposts. And you can run it on any other server. Okay, as long as it's vSphere for now, because the only cloud provider that is ready is vSphere or Docker. You can run it on-prem if you have vSphere or Docker. So for your development workload, you can run it on Docker. EKS integrates well with AWS service. So if you are an AWS customer and you're already making use of AWS services like RDS, Redshift, analytics, machine learning, anything basically, so basically EKS integrates very well with this. And you will see that SageMaker is using containers on the Corey blog. Another 17 ways to run containers. It's amazing. EKS with the EKS Anywhere and EKS itself enables hybrid and multi-cloud workloads. This is a big statement, but it is the roadmap and the direction I believe that is going to be. Imagine that if you have, without even EKS Anywhere, just with Outpost and local zones, I mean, EKS will enables hybrid. And the definition of multi-cloud and hybrid is sometimes vague, but just take my word for it. EKS, why should I use EKS? Why shouldn't I run my own Kubernetes? Why shouldn't I run Rancher or OpenShift? I can run OpenShift. I can run OpenShift, especially if I am running and have the OpenShift skills. Maybe I prefer to run OpenShift. If I have the VMware Tanz and VMware skills, maybe I should run VMware Tanz on top of AWS, on top of VMware. But basically, I use EKS because it's managed. So it takes out the operational concerns, the undifferentiated heavy lifting, and making sure the control plane is highly available, resilient. If a control plane node fails or corrupt or needs update, it will be updated. It's not a concern anymore. And basically fault tolerance across AZs. That's how they create the control plane. Okay. Oh, again, and let's talk about distractions. Okay, at least I'm mostly same thoughts. Okay. Now, one benefit of EKS that it follows the open source. It's CNCF conformant. That means that any product of the CNCF or any product for Kubernetes or for the cloud native ecosystem, because you will see that there are some political challenges sometimes with some of these tooling with some of these framework, like for example, Service Mesh Istio. It's not part of the CNCF, but there is another CNCF linker D is part of the CNCF. So, but in general, I can deploy any cloud native software, cloud native application, cloud native platform, cloud native, whatever you call it, like storage on top of EKS. So this is one of the benefits. So I have the AWS managed services and I have the rich system of CNCF. And the rich system of CNCF, do I need RDS? Do I need Aurora? Maybe I can use Vitas, and this is the MySQL cluster. For packaging, I can use Helm. For monitoring, I can use Prometheus and Grafana, and AWS is a big contributor to these two, and FluentD for logging, and so on and so on. Okay, by the way, this is like an old one. I mean, the new one, I don't think I can actually have it in one slide. Okay, so this was a chart that made it interesting. What are the primary reasons your organization is using Kubernetes? Basically, mostly programs, the area that need to mature, evolve. I found it interesting. I don't know why. I was looking for something that says that since 2000, so even before EKS, Kubernetes and containers were run mostly on AWS. So this is a statistic that is constant. And this is a statistic from Stack Rocks. You can get 1 or 5 statistics if you subscribe. So I subscribe just to get this one. And you see basically that the market share of Amazon EKS is still the highest. Kubernetes self-managed. This could be in AWS. This could be on other clouds. This could be on-prem. So this doesn't say much. And you see ECS, but it dropped 20% this year. So even ECS is getting lots of improvement. It's actually dropped in market share. Azure AKS, and Google JKE, they are quite the same. It's amazing that I see OpenShift here. I wanted to see OpenShift somewhere really in the top. Okay. So how does the architecture look like for EKS? So again, there will be a control plane, and as everything in AWS, it will be contained within a VPC, but we don't have access to it. It's managed completely by AWS. Vlad talked about the ECR, the Elastic Container Registry. Now, how about my worker nodes, my data plane? I can have managed instances, or I can self-manage the instances, or I can use the serverless option. Or what is not available here is that I can actually run it on my data center. Okay, so ZDNet made a good diagram for us. Thank you, ZDNet. And they describe the different options you have. So you have Amazon EKS, which is managed by AWS, and it's in the cloud. And you can run it EKS on public cloud, or you can run it on-prem, use on Outposts. So you have the deployment type. Of course, you cannot have Fargate because it doesn't make sense on-prem. I mean, you use Fargate to reduce the management. Maybe this will make sense, I'm not sure. But it will not make sense in terms of cost effectiveness. Okay, now EKS Anywhere is managed by customer, It uses EKS distro, which is the open source components of EKS. And from there, you can see what software is included in EKS. It runs on customer infrastructure, managed by customer infrastructure, can be supported by AWS. But read the, I think there are some constraints, like, for example, I'm not sure if you change the CNI from Cilium or if you change the GitOps from Flux, will the new integrations will be supported or not? I'm not really sure. So EKS distro, you can run it yourself and it's not supported. The difference between EKS Anywhere, it can be commercially supported by AWS. Okay, now creating a cluster on AWS is actually something I hate. And I just wanted to try to write a diagram of if you want to do it manually before having the tool. How can I do this? If you want to, basically, as in everything in AWS, you need an IAM. You need an IAM role, and you need to associate permission, and you need to attach a policy. You need a VPC. You need to think about the subnets, especially if you're thinking availability, reliability, and stuff like this. Do you need it public or private? The internet gateway, the routes, the route table, the security groups. And of course, I need the open source tool, kubecontrol, that manages my cluster. And of course, I need a way to make sure that I am authenticated and I can pull the config map, the kubeconfig that communicates with Kubernetes, that has the name of the cluster, the IP of the cluster, and the certificate that allows me to communicate with the cluster. And then the data plane, should I use managed or non-managed? And what CNI should I use? And what container registry? And how do I configure this? So all of this heavy lifting, you can use EKS control, create cluster, and it has so many flags and so many options. And this is the imperative way to run it. And of course, you can run it declarative using YAML file, which is the recommended way. It's from Weaveworks, and it's considered the AWS EKS tool, Amazon EKS tool, CLI tool for creating and managing clusters. Okay. Okay. Now, one thing we mentioned before, I'm okay, excuse me if these are out of order, but I'm a very big fan of AWS BottleRocket. And why? As I said, the history of Core OS. And again, because basically, if you care about day zero security, this is a purpose-built operating system. It's very minimal. You don't SSH to it. You manage it using APIs. So everything is managed using APIs, and it has two images, one running image, one configuration image, like it reminds me of the Cisco switches and how you manage switches before. So it is a minimal Linux distribution, mainly to run containers, maybe to run as a Kubernetes. It's immutable. There's very few places where you can write to, and it has automation in mind when it comes to updates and stuff like this. Okay. There was a question before regarding which scanner is used in AWS ECR, and it's Claire. And I made it. I forgot to do the other image. I did it at work, and basically the same image when I host it in AWS and I host it in Claire version 4. The number is slightly different, but it's a few differences, like 4 or 5 extra vulnerabilities. So it could be the different version, or it could be, I think they are using version 4 from the results. I can tell actually if they are using version 4 if I see vulnerabilities that are related to Python, because Claire version 2 was mostly system only. Okay, now exploration time. This is where I fail big time. Sysdig has something similar in terms of market share. I forgot to put it. I created a cluster and I created the Fargate profile to save time. Why Fargate? Because basically serverless always wins in the decisions. It focuses on application, not on infrastructure. So my focus on the king I don't waste time building infrastructure, updating it, maintaining it, especially during updates. I get scalability out of the box. So if my application scales, the cluster will scale with it. It reduces my operations and day two overhead, like updates and batching. That's for the infrastructure and the cluster. I still need to batch the images. If my image as ECR shows that has vulnerabilities, maybe I need to rebuild my images. And Fargate gives me better security isolation and cost efficient. When it comes to cost, I like this tool from learnkates.io. I tried it with AMD instances and I tried it with Intel instances. I mean, I couldn't really make a conclusion, but there are differences and it depends on, in Kubernetes, what matters is the memory and the CPU. Of course, the network matters and the other aspects of storage matters, but usually when
I can help you about this, Walid. So because I'm coming from, you know, HPE and infrastructure background, so AMD processors has higher cores and better CPU cycles or better clock speed cycles. And this is what makes the difference between it and the Intel part.
Yes, I was, yes, actually, thank you, Muhammad, because this is a good factor. So even if the price is the same, as Muhammad said, AMD processors like EPYC is basically, they provide you with better memory, more memory channels, better CPU. So basically you will get better memory bandwidth and things like this. So it's not like apples to apples, but this tool helps you find the cost. Actually, it is not just for AWS, it's for GCP and Azure. I like it, actually. I love it. I was playing with it this morning. Okay, before I leave you and before we do the exploration, there are learning resources. I missed the most important learning resource, which is the containers on the couch. Okay, but there is a free training from AWS. I think it's just for 1 hour. It's considered to be intermediate. Amazon Elastic Kubernetes Service, EKS Primer. I haven't really looked at it. There is also from continuous learning from Cube Academy Pro from VMware. Pro doesn't mean anything. It just means they need your information. So if you don't mind a gated website where you can give your information, you'll get access to long form courses. You'll get access to webcasts and events and I don't know what. And you get alerted about the new courses. I like it because I know some people, some very good professionals are actually developed some of the courses here, like from Sneak, from VMware, like Scott Law and others. Okay, now from YouTube, we have the container hero, Nana. She has a free course, 4 hours course. And we have the DevOps guy, an Australian, funny and very actually resourceful guy. And his webcast, I love them because they are 10 to 15 minutes. Nana is the same also. Her webcasts are 10 to 15 minutes. So with somebody who can get distracted easily, I can still really follow the webcast until the end. So he created a map of how to follow basically your Kubernetes journey. He covers EKS, I think, in a couple of his videos. And he doesn't cover EKS control. Nana covers EKS control. He covers the old way, which it's okay if you need to learn what goes under the hood. But other than that, I don't really recommend doing it the old way, using AWS CLI or using console. Okay, for learning Kubernetes, EKS is not a free tier. So I wouldn't recommend that you learn an EKS public cloud, but you might learn on EKS Anywhere on your laptop. Or if you want online, you can use Katacoda. There's lots of CNCF framework, CNCF software, and Kubernetes courses here. Actually, I have some also there. And if you want, I couldn't find EKS. There was an EKS course before 2 years ago, but it looks like they pulled it out from Quick Labs. Quick Labs is mostly Google now. They were bought by Google, but there are still some ECS related labs. If you are interested in doing these labs and you need credit, just get in touch with me. I need your email, by the way. I will not share it with anybody, but that's the way, how can I share credit? Okay, so if you need any of the ECS labs on Quick Labs, or even if you need Google Labs like GK or whatever, if you need access to Quick Labs, just let me know. Send me your email and I'll basically include you on the sharing. Okay, and that's all for the theory. How much time do we have?
We have time. Will you
Okay.
have time?
Any questions before we delve into? So basically, I have two clusters, one in London, one in Bahrain. Why do I have two? Because I started with Bahrain and it keeps failing. And it was not the fault of Bahrain, it was my fault. I wasn't looking at the errors. So the errors, I used an instance that is not available in Bahrain. Okay, actually, I think I missed that. Okay, I missed that. So one thing that when you define the instance, they need to be, especially in a node group, they need to be of the same memory size and the same CPU size, because this will help the scheduler. If you do them like different sizes, the scheduler doesn't differentiate between a node and the other. They assume that the nodes are the same, at least for now. Okay, so there is a tool from AWS under their GitHub open source repos, EC2 instance selector, that helps you selecting these. And I think it's included now in EKS control. I think now in EKS control, there is an option where you can select by memory size and CPU size, and it will select the right EC instance for you. Okay, so that was why I had two clusters. Oops, I changed my tab. Go back up. Okay, let's see the cluster. This is in Bahrain. So, in Bahrain, I have actually two. I managed to create one in Bahrain. Okay, good. You see, I forget a lot. So I have DXB stands for Dubai, and I have DXB Anywhere, or loading Amazon case has enabled communicate. The cluster must be in active state. I killed my cluster or what? Okay, it looks like my cluster is dead. Let's see, Docker BS. Yeah. I know why. Yes, I restarted the system. So they are not, okay. Docker BS -A. Okay, so this is my dead cluster. Okay, let's see if we can create it again. ls. So I have a configuration file, this one. So if you use EKS control, most likely this will look familiar to you. So as in any ABI in Kubernetes, it looks the same. You start with an ABI version, and this ABI version is specific for Anywhere. EKS, Anywhere EKS is a plugin for EKS control. I want to create a cluster. Metadata, I want the name of the cluster to be dev cluster. Let's change it. Let's call it dev1. Let's call it dev01. The cluster network, the supported cluster network by default for EKS Anywhere Selenium. This is the CIDR block for bots. So Mohammed, we have three networks. We have the host network, like the VMs, like EC2 network. We have the bots network, which is different. And we have the service network, which is also different. So there are three networks in Kubernetes. And now, depending on the CNI, you could have the same bots network and host network. I think could be the same if you are using BGP. I might be mistaken, but I believe I'm not. How many nodes you want for your control plane? In this case, because I'm running Docker provider, just one. But if I'm running vCenter provider, most likely I will select 3 for high availability. And for etcd, basically the best optimal replica for etcd is 3. More than 3, you will have communication overhead. So it's usually because of quorum, you need 3, 5, 7, 2 plus 1, and 2 n plus 1. But the best one, after heavy instrumentation and experimentation by Red Hat engineer, they found that the best one is actually 3. etcd is, it's not just network workload. It writes every 10 minutes to a disk, so it requires a fast disk. Now, the data center reference, this is basically the data center reference. The control plane, I just need etcd just 1, Kubernetes version 121, and count worker load 1. Okay, and here the name of the data center where I'm deploying this. Okay. Now, EKS control, the imperative way, you say EKS control create. There's no auto completion. Create cluster. I don't need to give it a name because the name is inside. I say dev cluster.yaml. Error. Unknown field spec. What did I do? Unknown field spec. No, it's correct. Sorry. Who can tell me what's the mistake? So I should use the plugin. So EKS control anywhere. Okay, now what it's doing, if I do control, if I do docker bs -a, docker bs, it's starting Docker images. Actually, it's starting a kind cluster to bootstrap. So if I watch this, -d for difference, -t. So basically, this is a kind cluster. So it's creating a kind cluster. Kind is Kubernetes in Docker. So it's creating 2 Docker images. First of all, it's creating 1 Docker image. It's creating a kind cluster. And from this kind cluster, it will bootstrap the EKS Anywhere cluster using something called Cluster API. And Cluster API has many providers. The provider I'm using now is actually Docker. Okay.
Walid,
I should have.
Walid, one question. Is this new? I thought only vCenter was supported.
No, since the beginning. So this is for developers because, I mean, what's the use cases? What's the main primary use case? Developer, you don't want to waste developers' money on running on EKS. They can have EKS compatible cluster, okay, on their laptop. And it only requires like 2 container images. How heavy is that? It's like kind, it's like any kind, but basically
because I use kind, but I didn't realize that EKS Anywhere has got support for this. This is really nice. I learned something.
So EKS is not running on kind. It uses kind to bootstrap EKS.
Bootstrap, yeah.
So it creates a kind cluster first. This kind cluster will bootstrap the EKS.
Yeah, I got it. Thank you.
Yes, I haven't tried it with more than 1 container, but I would love to try this. And I added the Rancher local provisioner. So network is handled by Cilium. Storage, load balancing is handled by Metal LB or KubeVib, and it's on the documentation. But I haven't seen in the documentation anything about storage. So you either create NFS because you cannot really utilize AWS services yet.
Yeah.
Though it's in the roadmap. So it will be there soon. But for storage, so I just used the local provisioner from Rancher and it worked. Okay, but you can use NFS provisioner also. You can create an NFS server and the reason I'm using it, I'm actually using it on Scaleway VM. Why I'm using it in Scaleway VM? I was experimenting with SE Linux on Ubuntu on my laptop, and I killed my laptop. I removed SE Linux, and it removed many core packages. I was able to recover it, but I was not able to run Docker efficiently anymore. So EKS Anywhere was kept failing on my laptop. So I said, let's spawn a Scaleway VM. Why is spawning Scaleway VM? Because I have credit in Scaleway, and I love Scaleway. And I just discovered that they created something like EKS Anywhere, like Kubernetes Anywhere. Basically, you can run a Kubernetes control plane on Scaleway and nodes from any other cloud, which makes sense, but I'm not sure about the latency, so I really need to try it. Because latency, I mean, imagine you're running in France or Amsterdam and you have something in Dubai or Bahrain, or we don't have Dubai yet, but we will have it next year, I guess. Okay, so so it checked that the Docker provider, because you have to be over a specific version, which is 120, which I think everybody is. It created the Bootstrap cluster, which is the kind we saw. It's installing the cluster API provider, which is in this case Docker. Okay, so it has some CLI tools. Node, I mean, if you are used kind, you know what is Node. It's basically the like an instance. It's a node actually. So there's lots of this will disappear. We will have two nodes at the end of this. So basically now you have the Bootstrap cluster and the EKS Anywhere cluster, but then the Bootstrap cluster will die. Creating new workload cluster, okay. Installing network on, man, it's actually faster because now I think I have the images. First time it took more than 20 minutes. But I still have to do the IAM roles. I have to, for the EKS, so I used it and I used EKS Connect to make sure that I can see it on the console. Okay, let's see the other cluster. Hope I didn't kill the other cluster. So what's the other cluster? Okay, so this cluster, now this is a new console, EKS console since December 2020, correct me, Vlad, since reInvent, I believe. So it's better than before. Okay, now at least you can see the nodes. You can see the workloads. Okay, this looks really empty. Let's go, let's go to the London one. Now the console is for visibility mostly. For what? No cluster found. What did I do? Okay. Okay, so I didn't upgrade. I selected a version less. So the AWS is a bit behind. They don't have 122. They have 121. But I didn't upgrade. I want to show you the upgrade procedure. And what do I have here in this cluster? So this cluster was created by EKS Control. I can show you the EKS Control. I have, if you can see, I have Fargate nodes and I have other type of nodes. So I have on-demand node group. That means that, for example, for workloads that I cannot really tolerate going down. And I have spot instance for workload like a stateless workload. Okay. And workloads, I wanted to create a realistic workload. So I used Argo CD, which is a continuous delivery platform used mostly for GitOps. I forget the name of the company that created it. It's famous with its consultancies. But they have like thousands of Kubernetes clusters, and this is the way also for visibility for them. Okay, so I have the XP product. This is where I am deploying my application via Argo CD. The other staging is the staging environment for the XP prod. Okay, now what is special about the XP prod? If we go to the configuration, and if I go to the compute, I have here Fargate profile. And the namespaces that are governed by the Fargate profile are the default. So anything running on default namespace or anything running on DXP prod will be what? Will be managed by Fargate instances. So it means that they will scale easily. If I haven't configured the autoscaler, they will scale easily. Okay, I didn't use the labels, I just used namespaces. Okay, now let's see. So okay, go back again. So I like the interface. I think it can be improved upon. There's lots of things that it's still missing. But workloads, what kind of workloads you run on Kubernetes? So you can see there is mostly deployment and daemon set. Now, daemon set, you cannot run a daemon set yourself on Fargate. AWS can run it for you. Like what? Like logging, like monitoring. But you cannot run it yourself. Anything related, okay, Fargate is very nice, is very useful. But what are the constraints where you cannot run Fargate? If you're running something related to the host, like what? Like you can mount volume, which is called hostbat, which is really a security issue. You shouldn't run it. And so it's usually run in daemon sets for monitoring or for security tools. So this is one constraint of Fargate. Okay. Configuration. So you can see the node groups, networking. You can see which VPC, which CNI I am using actually. And you can see the subnets. You can see the basic. I mean, if you look at the objects, okay, let's actually go to CloudFormation. So EKS control uses CloudFormation. And if you look at the resources and objects that to create your cluster, so you have the cluster itself, which is the control plane, and then you have the node groups that you connect to it. Okay, so if you look at the cluster and you look at the resources, see how many resources you have. You have security group, you have roles, IAM roles, elastic IPs, routes, route tables, VPC gateway attachment. So you have many things. If you go to the node group and you have launch template because you are doing auto scaling group, where is the resource? Yeah, so you have launch template, you have managed node group, and you have node instance role. Okay, so to forget all about this and do it in an easy way, just go the EX. Okay, the cluster is created, which is good. If I remember, if I do code control, let's do kubectx, which is a tool to see how many clusters I have. Okay, so I don't think it recognized this cluster. So where is the part where it says the kube config? There should be some statement here. EKS custom components, CRDs. What did we say about CRDs? These are the custom resource definition and controllers to extend the functionality of Kubernetes. So basically, EKS Anywhere uses CRDs to add-on manager like what? Like CNI, like core DNS. And then here, the GitHub toolkits is Flux. Writing cluster config file. Okay, yes, I remember now, sorry. So export kube config. So I need to export the file that defines how you interact with the cluster. It should be in my home directory, in my working directory. $pwd. Let's see if it created the directory or not. Let's, yes, so it should be here. Okay, so this should be it. Okay, let's export this. Okay, now if I do kube control, get nodes. So kube control is the main tool to interact with Kubernetes. Okay, I see I have two nodes. I have the control plane node, which has the brains, and I have the worker node. If I do kubectx, which shows me, Okay, so basically now, because I have overridden my kube config file, I can see only this cluster. If I unset it, and I can do a kubectx, I will see the other clusters. Okay, I don't want to reset it. Let's bring it back. Okay, so what can we do with this cluster? We can check pods, kube control, get pods, and all. Okay, just a second, let me kill the other ban. Okay, and let's do less, and let's reduce the. Okay, so what kind of pods are running? So I have pods running on kube system, like CVM for the network. Anything starts with CVM, this is related to network. The cluster DNS, which is core DNS, which is an add-on. You can update it using an add-on. I have the Kube API server, the brains. So this is something you will not see in EKS on public cloud. You have the controller manager. I have the proxy, which is per node. And I have the scheduler, which is part of the control plane. Actually, if I do -0 wide, I don't know if my screen will handle this. But I should see, for example, that the scheduler is running on this node, while the workload, the kube proxy, is running on a different node. So basically, you can see the controller plane component, they are running on the control plane node, like this, and so on. Okay, let's go back. And here, there is a cluster ABD system for the cluster provider. And you can see that the cluster API using kubeadm. So the cluster was bootstrapped using kubeadm. And you can see the provider, you should see, capd means cluster API for Docker. So basically the driver, the provider is using Docker. If it's vSphere, you'll see capv. If it's OpenStack, you'll see capo, and so on and so on. Okay. Okay, now let's go. Let me find my password. It's not okay. Let me find how to find the password. So Argo CD, when you install it, Argo CD admin password. When you install it, it has the password. It used to be the password part of the pod name, but now they have changed, which is good. Getting started. So to install it, you just create a namespace and then you apply a manifest. And then somewhere here, this is how to expose the load balancer. Login, yes, this one. So come on, terminal. So I need my password. Oh, because I am in the wrong cluster, I should set unset kube config, kubectx to check my context. I am on London. Okay, now I can do the password thing. I shouldn't do it in front of you. I hope you are nice guys. So you need the password and you need the route. Okay, if you can remember this route, or if you, oh, actually the password is there. I don't need to get it. Okay, so what do I see here? I see that I have Argo CD. I see that the setting is that I set one repository. You can set it here so that it makes it easier to choose. And I can see that we can actually deploy to many clusters. But I am deploying the Argo CD on the same cluster that I'm managing, which is not really, which is the catch-22. How can you provision a cluster while you are actually deploying the management tool inside it? So this is where Flux actually have a tool, like it can bootstrap. And Argo CD now, I think they have another tool. I haven't used it yet, Arc CLI. Okay, so this is the setting. It's very simple. And then you come back to an application. This is the application. So I have two applications. It's the same application, but I have environment production and I have environment staging. And I told you, Nuit, is it called the Nuit? Argo CD origin. It starts with Nuit. Is it Nuit or something like this? Anyway, the company that created Argo CD, one of their goals was actually the user interface. So now, if you look here, you know what kind of applications. You don't care about the infrastructure namespaces. You care about the production. You care about the users' namespaces where you are running user workloads. And you care about the production environment versus staging versus QA versus development, whatever. Yeah, so I have two environment. They are in sync with my Git repo. And this is my Git repo where I define, let's see, repos. So this is my Git repo where I have a project. And this project, I have a Helm chart, which defines my applications. Basically, it's a template that defines my application. And part of this template, so there is a value file. And this value file, I can change the namespace where I am deploying my application. I can change the replica count. I can update the image I'm using. I can do lots of things. Okay, and I have two templates. One defines a production environment and one defines a staging environment. If I come here to the production environment, it says that I should have 3 replica counts. And these are the resources I'm using. I'm going to use only 350 milli CPU and 128 megabyte of memory. Okay, now if I check here, this is the production. So you can see here, so the application called Tech Trends in the production, it requires a namespace. This is the namespace, the XP prod. It's managed by Fargate. It has a service. The service basically exposes the pods to the outside. Actually, it's I didn't expose it as a load balancer. I could do this, or I could expose it as ingress. And basically, it has a deployment. Now, the service has something called endpoints, and the endpoints is basically the pods. So it should has three. It should has three. Yeah, it should have 3 endpoints. The IP addresses of 3 pods. Okay. Okay. So I have a namespace. Under this namespace, there is a service, there is a deployment, and the deployment has how many? Has 3 pods. But it doesn't create the pods directly. It creates the replica set, and the replica set will create the replicas. And I said in my definition, I need 3 replicas. Okay. Let's monitor how many. Let's say let's monitor kube control get nodes. So how many nodes I have? I have 1, 2, 3, 4, 5, 6. Okay, let's do watch. And let's scale it up. Let's scale the application up. How do I scale the application up? I change the image, and the image requires, let's say, so basically I do it the GitOps way. The GitOps way, I don't change the cluster manually from the console or from anywhere. No, I change actually my source code, my desired state on Git. That's why the name GitOps. So I have something called the request and limits. The scheduler cares about the request. Let's say now I want 1,500, which is not true, but the scheduler will think that that's what I need. And let's say I need 10 replicas. Okay, just to watch the scale up trigger. The moment I commit this change, what do you think will happen? Argo CD is monitoring my repo. Okay. It says sync is okay, which is not true. Let's see, did I did commit, yes. Okay, so it should, let me refresh. Okay, okay. So it's recognizing that there's something app health, there's something weird going on. And you can see the deployment. Now I can see I have the 10 replicas. So I didn't change using kube control. I changed using the YAML file. And this change is recorded in Git. So I have the history of it. And basically, the Argo CD, the deployment, the continuous deployment framework, is trying to sync it now. Yeah. And if I look at the nodes, okay, I don't have one to, let me do. Minus D, minus T. So I have 1, 2, 3, 4, 5, 6 still. I didn't need to scale up the nodes yet, which is strange. I think, okay, maybe I need to request more. It depends on the node type instance, but the node instance I selected are small. Okay, so they are coming up. Let's see. Ah, here you are. So you see the Fargate. So I didn't do auto scale. I didn't really manage the scaling up of the node group. It's done for me automatically. That's the value of Fargate. So you see it now. Let's say, okay, let's go to the console. Let's do things. Let's go to the console. Forget stack. That's the Kubernetes service. Let's see the resiliency. Let's go to the cluster. Let's go to the XP cluster. Okay. Takes time to refresh. It has the new nodes, and most of them are Fargate nodes. Okay, and I have just one on demand. Okay. Now, Fargate, I cannot really manage it, can I? Okay, go back. So basically, I can see the labels, the conditions, memory pressure is good, false, disk pressure is false, ready. Okay, I can see Argo CD server running here, AWS node, and I can see the application is running also here, tech trends, but one pod only. Okay. Okay, let's go back. And if I go to the configuration, if I go to compute, and if I go to on demand, and I say edit, and I reduce. Okay, so I reduced my on demand. Actually, let me kill my on demand. I don't think I can kill it. So now I have two nodes on demand. One of them will disappear. I have 97 and 184. If you look, 97, yeah. So you see here, so this is going to disappear, but it doesn't disappear straight away. So what the cluster will do, the cluster will actually put it in scheduling disabled. So basically, it will try to drain it. It will try to migrate the workload. This is the self-healing. This is the migration. This is basically what we call resiliency and high availability. It's going to migrate the workload from this node that we killed to another node, okay? And if there is not enough space, and if it will actually provision an instance of Fargate to hold it in. And I think this is exactly what happened. No, it didn't happen. Almost all my ages are above 1 minute. Let's see after it finishes the scheduling disabled, if it creates another node, or if it will actually, there's enough space, enough capacity on these nodes already. Okay. Any questions? Anything you want to see? Because this is basically ad hoc, whatever you want to see. Whatever the audience wants. ما يطلبه المشاهدون in Arabic is a very famous Egyptian radio program. So Anas, Vlad, any comments?
No, not from my side. I was really interested in the Kubernetes. It's all new for me, Walid. Sorry.
Not from my side either. I actually learned a couple of interesting things that I didn't know. And yeah, again, everybody, this is a community event. This is the AWS user group. So we're here to answer your questions. Walid is here to showcase stuff that is interesting for you and to answer your questions. So this is your time to jump in.
Walid,
Okay.
I have a question. I was out for a bit because I had to make dinner. So you may have explained this. So in that case,
What dinner? What dinner did you have?
I'm just still eating like on my table.
Okay, just one second before you ask the question. I just want to go and do the update. The update really takes time in EKS. I just want to check. So I started the update, and we should see it also here. We should see the control plane nodes only. Okay, update, which we will not see because we don't see the control plane nodes. Okay, what's your question?
When you drain that, or when you mark that node group of on-demand, when you terminated that one instance, you mentioned that it goes to scheduling disabled, and then nodes, the workloads were automatically migrated. Is that done by some controller from AWS side? Is that some? If you mentioned that, I missed that. Sorry.
Okay, I'll do it again. So basically, I have node groups, and I'll show you how this was created.
Okay.
Are you familiar? Are you familiar with EKS control?
Yes.
Okay, good. So I have this definition. Okay. So basically, it's using the region London, EOS2, and I have 3 node groups. I actually used to have 3. So the first node group, I have AMD. Thank you, AMD, for your support. So basically, I have AMD instances. I wanted to check, I wanted to do like a benchmarking, but I was not able to. So I have a mix. So before I had like 3 instances, but then I had a typo that caused me to spend time troubleshooting, which actually, if I look at the logs, it was straightforward, but I didn't look at the logs, the output from EKS control. So I have C5 AMD, C5 large, C5D, T2 medium, and another AMD here. And this is London. And the London I can use, okay, you can see in London I can use older generation, which when it comes to spot instance, so what I'm trying to show here, I'm trying to show that with EKS you can have the flexibility. So if you have a stateless workload and you can, like rendering, video rendering, batch work, HPC, which is what they call loosely coupled. Yes, you might be looking to save cost. So you'll use spot instances. And the more instance type and the more availability zones, I didn't define availability zone, the more instance type and the more availability zones you define, the more chances you will get your spot instances. And then I have on the demand, these most likely will be for my stateful workloads. And I have Fargate profile because I wanted to show the serverless aspects of Fargate. But Fargate is not working for every namespace. So my workloads, remember what we said about workloads? We said that they are isolated by namespaces. So I can do kube control get minus ns for namespaces, or get ns for namespaces. I can see that I don't have many. I have Argo CD, which is having the Argo server and Argo controller, which is actually an extended CRD, an extended API. And I have the default namespace, which is really shouldn't be there. People use it for experimentation and stuff like this. And I have my production DXB prod. If I do kube control, get bots or get all minus n DXB prod, this is what my production workload is. I can see that the bots, the 10 replicas, I can see the service is exposed. I can see the deployment that is managing these, and I can see the replica set. And because I have scaled once, I can see an old one is not used anymore. If I scale again, most likely it will create another replica set. Or if I change the image, most likely it will create another replica set. But to answer your question, if I do get nodes, here I cannot see it clearly because I don't have labels. I should have labels. But you can see here there is Fargate at the beginning. These Fargates, I know that they are managing either DXB prod or default, and I haven't deployed anything to default. So most likely these are the ones that's basically my bot, because remember my configuration file? How many CPUs I have? I have 2 CPUs, yes? 2 virtual CPUs. And in my limit, in my GitHub, what did I say? The bot, what's the minimum request for the bot CPU? I said it needs 1.5 core. So it cannot, each node is hosting 1 core and wasting half a core. And that's what you see in the EKS and the Kate's cost. It actually gives you how much node waste you are doing when you select a certain type. So because of this request, let me lower this request, okay, so that we see the scale down. If I say I need 500 mils, that makes, sorry, not limits here. Let's say 300. So this will, basically this will make one node able to handle 4 bots, or at least, yes? And we leave it the same, replica count, leave it the same 10. And we go back to Argo CD. So Argo CD, let's refresh. I think it did refresh. It's killing now. So it's killing bots. No, it's not killing. Why is it? But there is something going on. There is some migration going on. Okay. If we look at the, I never tried this before because there is no descheduler really. So I'm not sure if it will happen or not. Kube control get nodes. I think yes, we have less, no? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No, we don't. It's still the same. But Fargate should be clever enough and know that it's running inefficiently and it should reduce. This is the theory. Now, will it happen or not? I don't know. If anybody else knows, let me know. Yes, okay, good.
Is that a Fargate thing or a scheduler thing?
No, this is Fargate.
Yeah, but Fargate is just compute. Wouldn't the scheduler have to?
Yes, but when you run a Fargate profile, the scheduler is a Fargate scheduler.
Fair point. Fair point.
Yeah. So one thing that there is an admission control. There is a if I remember correctly, the way Fargate works, basically it sees, are you the namespace? Are you the label that I am looking for? If you are, I will change your scheduler. Okay, so that I can schedule you on Fargate nodes. So I can basically take care of you. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Actually, it increased. What did I do wrong? 46. This is a newly created node. So, okay, still, the bots are still settling.
So it's because of your version upgrade?
Sorry?
Is this because of your version upgrade that the pods are being migrated?
I didn't upgrade the version. Okay, so I only reduced the requests. So the request should satisfy should if I look, okay, let's go back. XP Spot London. This is overview. Let's take one. This for 40 minutes ago. Okay, let's refresh first, because there should be like less a minute. Yes, that's it. Let's take this one. So this one should host 4. Yeah. Bots. It's hosting only 1. Let's see. Did I make something wrong in my capacity provision? 0.5. Yes. So with 0.5 virtual CPU, it should be able to host more. It's not hosting more. And that's so one way to solve this is to run something called descheduler. Descheduler will balance the number of pods on the nodes. That's how OpenShift does it. But I don't think it runs by default. You need to do it because it's disruptive to your workload. Okay. So my assumption was wrong. So my assumption that this will get reduced. Okay. I need to experiment more with that. Let's reduce the replicas and then scale it up again. Let's reduce the replicas because this will definitely reduce the number of nodes. So let's reduce the replicas to, let's say, 2 or 1 even. But you see how fast is the Argo CD is running? It's amazing. I mean, now some production shops, they will not give you kube control. They will just give you, they will basically monitor your repo, and you can only deploy to test developments. So, and the other stuff is all automated. So that way they can control the security and they can control the deployment better. Okay, so now I should see things getting killed. First, I should see here, the number of bots should be going less. Okay. Okay, it's starting. Okay, while this is working, I wanted only to show you what I like about the visibility here. Oh, this is going to be, this is not showing. Why is it not showing? Strange. I should see the YAML file, but I'm not seeing it. I guess during a transition, you'll not be able to see anything. Let's see the deployment. Okay, that's what I was trying to look for. So you see summary, the kind, the name, namespace, and whatever. And actually, what I like about this is that I can do that. So here is the main schema sections. So I have the spec, which is the desired state, status, which is the current state, metadata, which is metadata, and I have the ABI group and the kind. If I want to look at the metadata, there's lots of annotations, like creation and last applied change. I hate the managed field. And I have the name, the namespace, and the resource version. Okay, because it's deployment, I will not have owner because it's not owned by anybody. But if it's a replica set of its pod, I will have owner reference now, which tells me this pod is owned by replica set. Replica set, it's owned by deployment. Now, if I look at the spec, there is lots of stuff that we really don't cover. Progress deadline second. So basically, if I remember correctly, this is how many seconds if the bot didn't progress, and it will be killed and restarted again, I guess. Revision history limit 10. So you have, if you are doing rolling updates, what do you call them? The kube control rollout command. if you do this or the restart command, basically this is how many times you can see it in the rollout history. You have the liveness probe, which I didn't configure. Actually, it is configured. Okay. Actually, in this repo, there is a good example of how you create a microservice. Scheduler name, default scheduler. Now, I believe I shouldn't see default scheduler, but maybe it is at the pod level. Okay, let's refresh. I should see one pod. I said one pod. I'm still killing. So it's killing most of them, and it will keep this one, most likely. Yes. Let's see the scheduler. You see, Vlad? So what happened, because this is a Fargate managed, it changed the pod scheduler. It didn't change the deployment, but the end product of the deployment, which is the pod, it changed the scheduler from the default scheduler to Fargate scheduler so that it can manage it.
I agree with that, but so what you did on the deployment was you changed the requests and limits, right?
Exactly.
You were waiting for Fargate pods to go down.
Yes.
The scheduler, well,
yes.
a
Now
new rollout was supposed to happen of the deployment, and the pods should have been terminated and replaced.
That didn't happen, correct? So new rollout happened. What?
It's weird that it didn't happen.
Minus,
I agree with you there. I would have expected those pods to be terminated because those pods and those Fargate nodes are now.
So this is a rollout. Yes. So the latest rollout was 9 minutes. So another rollout happened. So basically, yes. So this is a rollout. So I have
something
here
to investigate.
Yeah, but no, what didn't happen is that Fargate, if you reduce the latency, if you reduce the, if you reduce the requests, okay, Fargate doesn't say, I'm running very light now, maybe I should consolidate. And I guess we need this scheduler for that.
But that's not really Fargate, is it? That's the pod.
Yes.
So the pod is running on Fargate. The pod should not be running anymore because it's part of the old replica set. The old replica set wasn't deleted properly.
Let's see.
It's what I'm thinking. Because Fargate is just it's indeed allocating a node, but it's doing that for every single pod.
Correct. Correct. Yes.
Maybe a pod disruption budget came in there. I don't know.
Yes. So one thing I missed in my slides is the mentioning of the Amazon EKS workshop. And when we initially talked with Anas regarding this series and with other organizers of Dubai Meetup, what we wanted to do more hands-on, and we wanted to follow EKS workshop. I love the EKS workshop, and I love Containers from the Coach, which is maintaining this site and making it more up-to-date and useful. Here is EKS Anywhere. That's new. Oh, that's just a link. Okay. They did cover EKS Anywhere in Containers on the Couch twice, one with Jeff Barr. It was like a high-level coverage. Okay, here's how you launch using EKS control, console credentials. So there is lots of things that one can follow here. Okay. If you need credit, talk to Anas. Okay, what time is it?